Hi, and welcome to FreshMind.com. My name is Eric, and we're going to talk about gamma correction. Gamma correction is important to understand because it will allow you to display your textures and images on your computer in an accurate manner. And to explain that, I'm going to do a little graph here. Let's let me draw a square, or a box rather. Now, your computer screen has a bunch of pixels all over it, and those pixels can vary in brightness. That brightness is determined by how much voltage is being supplied. So let's say we have a little graph here, and at the bottom, let's say we've got our voltage, and over here on the right, we've got our brightness. All right, in a perfect world, 0% voltage, if you don't have any voltage, you're not going to have any brightness. So the brightness equals 0. If you have 100% voltage, then that's going to equal 100% brightness. And if you have 50% voltage, that's going to end up being 50% brightness. We can depict that by drawing a line like so. So if we had 75, if the computer was supplying 75% voltage, then we would see a pixel that is 75% bright. If the computer is putting out 25% voltage, then the pixel should be 25% bright. So simple enough. However, our computers unfortunately don't work that way, or at least our computer monitors. They have a curve more like this. So if we look at this curve here, 100% voltage still puts out 100% brightness. 0% voltage still puts out 0% brightness. But everything in the middle now is different. It changes. So if our computer puts out 50% voltage, we actually get less than 20% brightness now. So what does that mean? That means if you take a picture that is, let's say just a gray picture where all the pixels are supposed to be 50% bright, and you try to view that on your computer, that image is going to look darker. So let me just kind of simplify this here. Here's our picture. It's a certain amount of gray. We try to display it on our computer, and it's going to come out looking like this because of the way the voltage affects the brightness of those pixels. Okay, let's see how this behaves inside Maya. I created a little scene here, just a little room with some objects, and if we do a render, this is what we get. It's got default lighting, so no shadows or anything. So let's go ahead and add a light. Let's say we're wanting to light this up. Since we're talking about the brightness of pixels, I'm going to create a light. Let's create light spotlight. Just going to raise this up. I'm going to press number 7 on my keyboard so I can see what the light's doing. I'm also going to press the letter T. It gives me these 2 handles, and now I can adjust where the light's pointing. And I can adjust the light itself. I'm just going to put it up in this corner over here. Alright, good enough. I'm going to open up the attributes for that light, and I'm going to change the decay rate to something more realistic. So let's change it to quadratic. The cone angle, I'll make it bigger, maybe not too big. And since we changed the decay rate to quadratic, we really need to bump up this intensity. So let's try 10, 50, 100, 200, 300. Alright, so we'll try 300. That's looking pretty good. Let's turn on some shadows. So I'm going to go down here to the shadows. We'll just use depth match shadows, and I'm just going to leave it on default. Alright, render settings. Maya software. I got it on highest quality, and that's all I've done. Close. Zoom in here, and let's go ahead and do a render. Alright, so we've got some shadows. We've got some really bright hot spots, and even though our light is this bright, look at the room. It's still not really lit up the way you would want it to be lit up. And the reason being is we've told Maya to make our light a certain brightness, which that light controls the brightness of all these pixels, but it's going to come out darker in areas because of the way our monitor behaves. So what we want to do is, since our computer behaves this way with this curve, we want the computer, or we want some way, whoops, let me undo that, let me add a curve. we want some way to add this curve so that it cancels each other out, and what we end up with is a straight line like over here on the left. So if we could add this blue curve somehow to cancel out this red curve, which is the way our computer monitor works, then we'll end up with a straight line where every color is exactly as bright as it's supposed to be. So let's go into Maya, and we're using Maya software. We'll start with Maya software, and then we'll do the Mental Ray. So Maya software, let's keep this image. Open up the render settings, and what we're going to do is we're going to tell Maya to compensate for that 2.2 value. And I don't know if I mentioned that or not. I did not. Okay, this curve right here can be represented, or all these curves can be represented by an equation of, since we're using voltage and brightness, let's just say brightness equals voltage to the power of some number. All right, this over here on the left, which is straight, is going to be brightness equals voltage to the power of 1. So basically, brightness equals voltage. 50% voltage, 50% brightness. This red curve over here can be represented by brightness equals voltage. Now, not all computers are exactly the same. Most, I think, are 2.2. Don't hold me to this, but I think some Macs or might be 1.8. Seems like I've read that before. I think some older monitors might have been 2.5, but I think most computer monitors nowadays are 2.2. So this curve right here is represented by this equation. B equals, or basically some value, what your output value is going to equal your input value raised to the power of 2.2. That 2.2 is what we want to keep in mind, what we want to remember. All right. Let's go back inside Maya. My computer screen is 2.2. Chances are yours is probably 2.2. So I'm going to go in here inside Maya software tab. I'm going to scroll it down to render options. I'm going to expand that, and you will see gamma correction right there. I'm going to tell Maya to compensate for a gamma of 2.2. So what's going to happen is Maya is going to apply this blue curve. And this blue curve is actually, since it's the opposite of this red, it's 1 divided by 2.2, which is basically B equals V to the power of 0.454545. So by telling Maya to compensate for a gamma of 2.2, we're telling Maya to compensate for this red curve. Maya is going to apply that blue curve, or it's going to apply a value of 0.454. But right here, all Maya is asking for is, hey, what gamma value do you want to compensate for? So let's go ahead and render this out. And let's compare the two. You can clearly see the difference now. So now we just compensated for the way our monitor works, and now our lighting is much, much better. If you look at the hotspot, it's still the same. It's not any brighter. But if you look at the rest of the room, everything's much, much lit up, much better. But as a beginner, typically most beginners in Maya, they don't know about all that, and so their renders end up being like this. They're trying to increase their light to try to make it brighter, but it just end up, it's just really hard. So you always want to tell Maya, tell the computer to say, hey, I want my light to have gamma correction. All right, now let's go into Mental Ray and let's talk about how to do it in Mental Ray. Let's go ahead and keep that. In Mental Ray, I'm going to use an outdoor scene. So I'm going to hide all this, add that light to our inside layer. And I have an outdoor scene here, just a simple brick wall that I had some textures. This texture, I just basically just went across the street to a building and just took a picture of the wall and just used that as a texture. Afterwards, I decided I'd put something else in the scene so it wasn't so dull. So I decided to put a crate. I found a crate texture on a website, dougturner.net, DOUGTURNER.net. So dougturner.net is where I got this texture at. So if you go there, you can probably find that. Let's go ahead and switch to a mental ray render. Quality, I'll put it on preview. Actually, it doesn't really matter. Let's go ahead and do a render like it is now. Okay, we have no light. So let's add a light. And I think I must have turned off. Yeah, because we've got over here, if you go to your render settings and you go to the common tab, scroll to the very bottom, you'll see render options. If you expand that, you'll see enable default light. When you add a light to your scene, it automatically disables that light. No matter if there's a check mark there or not, that light does no longer exist right now because we created this light in our scene. Once you create a light, then that default light it does not calculate it anymore. So let's go ahead and add a light. I'm going to go ahead and do a directional light. Got the letter T pressed, so I've got these two handles here. I'm going to press number 7 so I can see what the light's doing. Let's kind of adjust this more like the sun. Alright, here we go. And let's make some shadows. Since we're using Mental Ray, we can use Ray Trace shadows. You can use Ray Trace shadows for Maya software too, but you have to turn on the ray tracing in the software render settings. Let's see. We can leave everything default. Let's just go ahead and say 5 for the light angle, which will make the shadows a little bit softer. And let's say our shadow rays 64. That way they're not too speckled. And let's do a render. Alright, I'm going to go ahead and stop right there and just make our light a little bit brighter. Something about like that. Alright, so there is our render. It actually looks pretty good. Our bricks look, just like it's supposed to look. But as far as the lighting goes, I've got the lighting cranked up. But we haven't added any gamma correction to our light inside Mental Ray. We can actually do the same thing. The way, at least my preference for doing it is, let me just close this out, is a little more complicated than it is in the Maya software. Alright, I'm going to go open up the Hypershade. So Windows, Rendering Editors, Hypershade. I'm going to go up here at the top. You'll see some tabs: Materials, Textures, Utilities, Lights, Cameras. I'm going to click on this perspective camera because that's what we're looking through. We're looking through the perspective camera. And I'm going to show all the inputs for it. So I'm just going to click on this Input Connections. And we don't have anything connected to it. Over here in the left-hand column, I'm going to scroll all the way down. Or actually, let me change it. I'm going to right-click right here where it says Create All Nodes. I want to right-click, and I'm going to select Create Mental Ray Nodes. And I'm going to look for lenses. There's our lenses right there. I'm just going to expand that. And there's MIA underscore exposure underscore simple. I'm going to click it. Puts it down here in the work area. This right here is a lens shader. We're going to attach this lens shader to our camera. I'm going to before we do that, let me just show you. I'm going to double click on it. It opened up the attributes for it. If you look over here in the attribute editor, you'll see right there, gamma 2.200. So Maya is going to compensate for gamma of 2.200. Alright, let's attach that to our camera. So I'm just going to middle mouse drag and drop that onto our perspective camera node. And I'm going to select default. So now if we do a render, our light now is much brighter. It's because it's dark there, it's much brighter there. Now we'll talk about the textures here in a little bit. Just ignore the textures, they're washed out, but ignore that there. We'll talk about that here shortly. But all we did right now was we attached this lens shader MIA underscore exposure simple, we attach that lens shader to our camera. And so everything we're looking at through our camera is now being gamma corrected. It's compensating for that 2.2. It's compensating for that red line right there. Alright, now as far as textures go, I'm going to go ahead and delete this, my exposure. There, it's gone. I just deleted it. I'm also going to delete this light, or directional light. Let's do a render just to make sure everything's off. Okay, everything's off. Alright, beginners, a lot of times they like to use physical sun and sky. I like to use it. It's got great results. So let's go ahead and do that. Let's open up our render settings. There's mental ray. Let's go to our indirect lighting tab, and there is physical sun and sky. We're going to do now. I want you to notice right down here, final gathering. There's no final gathering. As soon as we click on physical sun and sky, now we've got some final gathering. Final gathering kind of simulates bounce light a little bit, so the shadows won't look so black. Okay, now that we've created that physical sun and sky, I'm going to make an adjustment here real quick. I'm going to open up my outliner, and I'm going to click on our sun direction light, which is just a directional light that was automatically created when we created that physical sun and sky. I've got the letter T pressed, or not holding down, but if there's W, E, R, and the T button, press the letter T, you get these two handles. And I'm going to also press number 7 so I can see what the light's doing. And I'm going to try to adjust this kind of like we had the other one. They're pretty close. So something about like that. Alright, let's go ahead and do a render and see what this looks like. Everything is nice and bright. So this is what you get when you use the physical sun and sky. You get a scene that looks really nice. It's got some realism to it, but all our textures are washed out, just like it was before. Well, why is it so bright anyways? Is it just that the light intensity is turned up so much? Because we haven't done anything to tell Maya to compensate for that 2.2 gamma. Well, actually, it did it for you. So if we save this image, close this out, let's go back into our Hypershade. I'm going to click on the tab for cameras, click on our perspective camera, and click on the input connections. And look what it did. It created this physical sky, sun direction, and it also created that MIA underscore exposure underscore simple node. And if we double click it, open the attributes for it, there's the gamma 2.2. So by creating that physical sun and sky, it automatically creates that node, that lens shader, that tells Maya to compensate for that 2.2 gamma. But the problem now is our textures are all washed out. Why is that? Okay, let's go back into this right here. Alright, we know our computer has this red curve. The voltage affects the brightness according to this red curve. This gamma value of 2.2, or this, I think they call this equation the power law. But when you take a picture, it's got a, it's straight like this. And what happens is that brick texture that I had, I went across the street with my camera, took a picture of that wall, and when I took a picture of that texture, that wall, my camera automatically added a correction to the brightness values of that image. And it added this blue line. So it basically added a correction like this. So my camera has already compensated for the way that my computer works. So now the areas that's supposed to be 50% bright are now a lot brighter. But that's okay, because once it's put into my computer, it's going to make it darker, and it's going to end up being exactly the way it's supposed to be. But inside Maya, we added a lens shader to compensate for that 2.2 gamma. So what's happening is our texture, before it came into Maya, got gamma corrected by my camera. And then inside Maya, we're correcting the gamma again, so it's becoming twice as bright as it should be. So what we need to do now is for those that texture, or for those textures, we need to cancel out one of those corrections. I guess that's the best way I can explain it. So over here in my Hypershade, see, here's my wall shader. I'm just going to select it. I'm going to click on the Input Connections button up here. It graphs out the inputs for it. Here's the texture file. Now this right here is the same texture file, except I just took out the color information just to make it a bump. And then there's my bump node, so just ignore these. This right here is the placement node. It just tells Maya how to place our file. But the main thing I'm really worried about is this right here. This is the color file. This is our brick texture. And this is our shader. I've got it plugged into the color. So if I take this line right here and I just click on it to highlight it and then hit the delete button, it breaks that connection. So now my wall is gray because our file is no longer connected. What I want to do is over here in the left hand column, right at the top, I'm going to right click and I'm going to select create all nodes. Alright, I'm going to scroll all the way down to color utilities right here, color utilities. And in there you'll see a node that says gamma correct. I'm just going to click on it. It puts that gamma correct node inside the work area. I'm just going to move it over next to my texture file. And what I'm going to do is I'm going to take this texture and I'm going to run it through this gamma correction and then plug it into the color of our shader. So what I'm going to do that is I'm going to middle mouse drag the texture onto the gamma correct, and I'm going to choose value, not gamma, but value. And then I'm going to middle mouse drag the gamma correct node onto the shader node and select color. So our texture is now connected to our shader just like it was before, but this time it's going through this gamma correction node. If I double click on this gamma correction node, it opens up the attributes for it, and right here's our red, green, and blue gamma values. If we look over here, that blue line, that value is 0.454545. So over here, I'm going to type in 0.45, 0.45, 0.45. Or you can do 0.454, 454, 454. So now I basically just told Maya to correct or compensate for that for a gamma value of 0.454. So now if we go to and re-render this out, our brick wall should now be less bright. Alright, so now our brick wall has our color back the way it's supposed to be. Alright, just explain that one more time. Our texture was corrected, had gamma correction already added on there. It already was compensated for that red line. And then we took it into Maya. We told Maya to compensate for that red line again. So basically this blue line was added twice. So what we did was we went to the Hypershade and we took our texture file and we just added a node, so that way it doesn't affect our whole scene, it only affects our texture. And by running our texture through this gamma correct node, we told it to correct for a value of 0.454, or this blue line, which brings our gamma back to what it should be. So I hope that was not too confusing for you. I hope you understood. Let's do that with the my crate texture. So I'm going to select the crate texture. I'm going to click on the input connections. Here's our texture. I'm also running it through a bump. I'm just using the same texture for a bump map as well. So I've got it as a bump and I've got it as a color. Alright, I'm going to select the color, just that line connecting it. I'm going to hit the delete button just to break that connection. I'm going to click on the gamma correct node, plug the middle mouse drag the texture onto the gamma correct node, select value, middle mouse drag the gamma correct node onto the shader node, select color, I want to make sure I got the gamma node attribute selected. Change the value to 0.454, 0.454, 0.454. Let me render this out. All right, and that is gamma correction right there. Now, I don't need to add gamma correction to the bump because, again, I'm not worried about my bump. I'm not really looking at it visually, except it's just adjusting the height, the depth of the texture. So it's not really adjusting how the texture itself looks as far as colors or brightness or any of that kind of stuff. So I don't need to add gamma correction to the bump values. But that's it. So if you ever use physical sun and sky and you wonder why your textures are always washed out, it's because if you were like me and went and took a picture, then your camera adds gamma correction or gamma encoding into the file, and then you bring it into Maya, and then when you use that physical sun, it compensates for that again. So now you're getting a double correction on that texture. So that's why it ends up washed out. So all you gotta do is just create this gamma correct node, run your texture through it, set the value of what this blue line is, which for most people is going to be 0.454, and then you should end up with a nice looking render. Now there's more to it than that. I just tried to make it as simple as possible, but there's definitely more to gamma correction than what I've shown. You can also have everything linear, where there's no gamma correction whatsoever, not on the textures, not on the lighting, not on anything, and then do it all in post-processing. There's other settings that a lot of people like to use, like instead of 2.2, a lot of people will use a 1.8, which will give more of a kind of like a film feel to it. So you can experiment with those values. You don't have to stick with that 2.2. That's just kind of a typical number for most people. And so I hope that helps clear things up for you. And as always, we thank you for watching.